Hey, welcome back to Math with Patrick. It's June 10th, and we're solving problem number 161 from the Daily Epsilon calendar. And let's show why this blue length, labeled with an X, is just equal to 10 today. So I see we got a circle, we got a triangle, we have an isosceles triangle. I know that when two of the angles are congruent, the corresponding symmetrical sides are also congruent. We have some lengths. Well, I guess we have a length here. And we need to do something with this 45 degrees, with this 10 root 2 to solve for this blue length. And so the first thing that I wanted to kind of explore was like the angles of the triangle. It's isosceles. I know I could solve for these, and so maybe that's kind of important. We could just do 180 minus 45 degrees to get how many degrees should be split among the two here, and this should be equal to 135 degrees. And so I guess we could then divide that by 2, and this at least shows that we have 67.5 degrees in each of these spots. Now, that's not actually that too helpful, I don't think, just because the blue line that we're studying doesn't really use that 67.5 degrees. So maybe there's other things we could do. Usually in these diagrams, a good strategy is just to draw as many radii as you can. So from the center of the circle to the points of the triangle are going to be more radii. And so we could try to solve for any of these x's right here. And I think I'm actually noticing something. I don't need this bottom one, but I do want that top left radius. And I want to show why I know this is 45 degrees. Well, first off, we could use something called the central angle theorem. Anytime you have an inscribed angle that joins at 2 points, and those 2 points then make a central angle, there's always this relationship that the central angle is double that of the inscribed angle. And so that shows that we have a 90-degree angle here. I'm wondering if that's the only way to do it, though. I don't know. It's just the first thing that came to mind. Maybe there's other ways to do it, thinking about those 67.5 degrees. I'm not really sure. Anyways, though, I'm pretty confident that we have a 90-degree angle, knowing that these two angles have a doubling relationship. Now that I have a right triangle, to me it looks pretty straightforward. And we definitely have an isosceles right triangle, right? Because these are both labeled with an X. This is labeled with a 10 root 2. And here's me just kind of showing that definitely it's isosceles because those two angles are congruent. And in 45, 45, 90 triangles, like this one, the side lengths have a relationship that's proportional to 1, 1, and root 2. You could prove this to yourself over here with the Pythagorean theorem. And so this essentially just tells me that x is 10, because I can see that if this were a 10, I could multiply by a root 2 to get that hypotenuse, that 10 root 2. So kind of cool problem. I like how this chord in the circle turned into the hypotenuse of a right triangle. And I was able to use that 45, 45, 90 triangle, that special right triangle knowledge to generate the answer for today. So that's really about it. I'll see you in the next video. All right, bye.